It now gives me great pleasure to ask Andy Hayes from IBM to come to the microphone. Thank you, Andy.
Good morning, everybody. As the slide says, my name's Andy Hayes. I work for IBM, and so my interest is really on the innovation and technology line item of Peter's slide 5 things, which is really about how you creatively apply technology to innovate and be more productive. There's a line we sometimes use, which is really if you've got a dumb competitor, a dumb competitor is easy to beat. If you've got a smart competitor, then really you can only beat them either by having data, information that they don't have, and therefore they can't do the same as you, or if they have the same information as you, use that information in a way that they've not thought about. And so what I'm going to talk about really is data or facts, because all this data we have in organisation are really facts. What that impact on that is on productivity and how technology analytics can be applied in order to improve the way that an organisation uses those raw facts and gets to the point where you can make a decision, quicker, better, faster, smarter, whatever word you want to stick on it, than other organisations. So, I would argue that the problem that we have in this world is that every person, every organisation, large or small, whether they're government or private sector, has more data than what they know what to do with, and data is being created faster than we can think. And that data is actually an enemy of productivity, because our poor Mark I human brains have not evolved over the past 5,000 years to the same shape as that curve. Any one of us presented with 5 facts can produce a decision based on it like that. Give us 50 facts, takes a lot longer. Give us 500 facts, and we start not processing those facts. We start guessing or making intuitive decisions, depending on which way you want to look at it. So our problem is that how do we deal with that data, those facts, but actually get to something useful, which I term actionable insight, so I can make a business decision. Whether that's about competitive, whether it's about how I do something more efficiently, whatever that business decision is, the challenge is how do I process facts and end up with something that is actually useful to me as a business decision maker. Lesson from history. In 1899, when the British Empire was at its peak, 25% of the Earth's land surface, 20% of the world's population, the foreign colonial and Indian offices were staffed by about 100 people. I suspect that didn't include the cleaners, tea ladies, couriers, doormen, and people like that. But in effect, arguably the largest organisation, the largest business the world has ever seen, was run by 100 people. And what's more, those 100 people didn't get into the office till about 10 o'clock in the morning and went home at 3:30 and had long lunch hours. Perhaps because they had so little data to work with. They got a memo once every quarter or once every year from each of the colonial outposts. It had relatively few facts on it, and frankly, there were only 2 things they could do. They could either ignore it, or they could send the Navy. And if they sent the Navy, they either bombarded, or they sent the captain ashore to negotiate. That was all they could do. So life was simple. Our problem is that even the smallest one-man company has more facts than they did. So how do we deal with them? If you think about it sort of intellectually, there's this sort of what I term the information pyramid, which says, we've got all these facts, all this data at the bottom. We need to associate those facts to turn it into information. we need to contextualize that information to create knowledge. We can create inferences from that knowledge to have insight. And we can conclude that if we do this, then this will be the outcome. And from a business, organizational, operational perspective, basically the faster we can get up that pyramid, the more effective and efficient we are. But as that base is growing and growing and growing, again, another trait of the Mark I human being, we find it very difficult to ignore facts once we're presented to us. So the fact that an organization has data sort of means it's got to do something with it. It's very difficult sort of emotionally to say, now I'm going to ignore that because it'll just make my decision-making process too difficult. So the challenge is, how do I go through that process and get actionable, my actionable insight as quickly and effectively as possible without employing thousands of people to assemble and do boring stuff with this data to provide me with the basis. And really, that's where technology can be applied. Because I can apply technology, and most organizations have been applying technology to take data and present it as information. The standard reporting tools that organizations use, we dress it up as business intelligence, but putting data together, presenting it in front of somebody so they can look at it and think about it. That's really going from data to information. If you start applying statistics to it, you can potentially turn that information into knowledge. But it's then when you start thinking about what's actually going on in that information, that data, that knowledge, can I infer from that data and create models? Can I take what my best employee does when he looks at that information, that knowledge, and says, actually what's going on here is, can I capture that in technology and use technology to do those inferences, create my insight? And that's where predictive analytical techniques come in. And if I start assembling multiple models and multiple predictive analytical techniques and statistical techniques, then I can create complex models. And I can create complex models which basically take my data and give me something that I can make a business decision on. And if I can do that faster than my competitor, more reliably, more efficiently, then I can make better decisions quicker, more effectively. That makes me more competitive. So what I've got next are basically 4 examples of using analytical techniques in different ways. And this first one is, organizations deal with people and other organizations, whether they're customers, consumers, business partners, suppliers, whoever they are, employees, contractors, all those entities that an organization deals with. Actually understanding those entities so that you make the right decision about how you deal with this entity versus that entity versus another entity is hard if you don't actually have a full picture of who that entity is, who they're related to, and so on and so forth. Now, I'm Canberra-based, so I spend most of my time working with federal government customers. So if you take an example from that, if you've got somebody applying for a visa, what DIAC care about is this a good person or is this a bad person? Will they go bad somewhere down the track? Knowing who that they know, who they're related to in some way, who they may have interactions with, affects their decision-making process. So if I can take those fragments of information about organizations and people, and I can magically create a picture, a map of who that person is and who they know, I can make better decisions. Now, there's nothing to stop me from trawling through the information in my my enterprise, my organization, and trying to assemble that. But in reality, it doesn't happen. So you give this customer more credit, they go bad. Had you known that somebody associated with that company was associated with a company that went bankrupt 3 years ago, you might have made a different decision. So applying analytics to understanding who you know and who you deal with can improve decision making. Second example, this comes from a German bakery chain where there was a sort of folk knowledge that they sold different products and different mixes of products depending on what the weather was like. Apparently, we as human beings buy different bread and cakes depending on whether it's raining or sunny or whatever it is. And so that folk wisdom was present in different degrees in their various outlets across Germany. But each of the managers of each outlet was going through the process of, some of them were looking at the weather forecast, some of them were forgetting to look at the weather forecast for tomorrow. They were then filling out an order sheet and placing their order for the next day's deliveries. And they were spending a fair amount of time. Some of them were much more efficient at it than others, and so on and so forth. So if you take the point of sale data that each store has got, you know what products are being sold. The Bureau of Meteorology, or whatever the German equivalent is, knows what the weather was like over the past. You can create a model which says, simplistically, if it's raining, your mix of products in this store will be that. If it's sunny, your mix of products will be this. So I can achieve two things with that. What I can do is I can take the next day's weather forecast and I can say, okay, what mix of products should this store have? And I can get it a lot closer to what I will actually sell. But also, I can save the store staff the 3-4 hours a week effort actually writing down or creating that order list. So I get two benefits. I save time and money out of my staff, and I get a better result. This is sort of almost the other end of the spectrum, which is the problem a telecommunications operator has, is that it has literally billions of facts. It knows, where I am right at this minute. It knows who I called last. It's got data for all that stuff. But what it really wants to know is who should I spend money on to maximise the value of retaining specific customers. My marketing budget, my sales budget is so big, I want to spend it to target those customers who will deliver most value to me. So you can take all that data and you can turn it into information that says, these people call each other. You can then start creating networks which say, okay, if I look at who calls whom, I can see clusters of activity. And I can start to identify patterns of activity. So I can identify cliques. What I've got is a bunch of subscribers, and most of the time they only talk to each other. I can identify stars, where I've got a large number of subscribers, but there is a smaller number at the centre who are in effect my key customers. And I can identify networks where I can see who are the gatekeepers between those networks. And if I can identify those key individuals, I can then spend my marketing and sales dollars on retaining those, rather than just doing general advertising, coming up with standard call plans, and so on and so forth. And the final example, I like, partly because I worked on it, and partly because it was a very creative way of actually getting the data that we didn't already have. So this is the Singapore Land Transport Authority. And they challenged us to say, how can you predict what the traffic on our road network will be? Not strategically next year, the year after, and so on and so forth, but in the next hour. What I want to know is where the traffic jams will be, what the load on the traffic network will be in the next hour. So I can make operational decisions about how I manage the lights, manage the buses and all that sort of stuff. Now, the conventional ways of doing this are you use simulation. So you take all your historic data, you feed it in, you run a simulation model, and 3 days later it gives you an answer. Not much use if you want the answer for the next hour. So we created a statistical prediction which allowed us to predict what the traffic on every road segment within Singapore would be over the next 5 minutes, 10 minutes, 15 minutes, 30 minutes, 45 minutes, and every hour. But the problem was that we didn't actually have a source of data. We didn't actually have a means of measuring what the traffic was. Until some bright spark came along and said, well, actually, every taxi in Singapore beeps its position, its speed and direction every couple of minutes. So you could use those as mobile sensors for the state of the road network. So, now we've got that, we can create a map of what the traffic is actually like at this minute, and we can start doing our predictions. And actually, the correlation between reality and prediction was pretty damn good. Best part of 90%. So it's an example of, if you like, identifying a business need and being creative about how you then find the data that allows you to meet that need. Thank you.